Welcome back. I'm Miss Latimer with EEI, and I'm here to talk to you some more about water. So far we've talked about, let's see, how much water we have, salt water versus fresh water, the water cycle, the urban water cycle, and wetlands. Today we're going to talk about another place we can find fresh water. It's called an aquifer. Alright, so an aquifer, have you ever heard of groundwater? Okay, aquifers are a type of groundwater. Deep underground, under all the layers, we find the aquifers. They're kind of like a giant underground lake. When we talked about where we get water from in our urban water cycle lesson, we talked about rural areas and them drilling wells. When you drill a well, they're into an aquifer. All right. In Texas, we have 9 major aquifers and about 22 minor aquifers. And that water supply makes up a little over half of all the water supply in Texas. And when we look at that, guys, those aquifers, the numbers where that water goes, about 76% is going to irrigation. Okay? That irrigation is for our crops, the food that we eat, the cotton to make our clothes. Okay, so a lot of that goes into that irrigation. But there are some places that use the aquifers for their city's water supply. Even, we don't. In Dallas, we use those 6 lakes, but there are some places that do that. Today what we're going to do is we're going to build an aquifer, and as we do that, we're going to test how much water each of the surfaces we're talking about holds. And then we are going to see how it works. Go with that. Talk about recharge, and I'm ready if you are. All right, all you need is a cup. We have our cup. It's the first thing we're going to do. We're going to test hardscape. In our wetlands lesson, we talked about hardscape. We even used plastic to test it versus a wetland. In this one, we're not testing against anything except to see how much water it holds. Our hardscape, kind of like the streets and the sidewalks outside, does not absorb water. Water runs off of it, right? So what we're going to look for is runoff. I'm going to use one of our pipettes here to rain right in the middle, and as soon as water runs off and touches the side, that's when I'll know that I'm done. Okay, so we're going to count 1 drop at a time and see how many it takes. How many do you think it will take? Let's see. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. All right, so we got 34 drops. So I don't know what you guessed, but the first time I did this, my hypothesis was definitely not 34. I thought that it was going to hold way less before it ran off to the side. But the way water works, when those drops hit each other, there's this cohesion. They stick together, and then when they run off, they all move together. That's why floods can be so dangerous. That water all clumps up together and moves so quickly, right? So we talked a little bit about that, and that's that runoff. When the rain hits the ground and it runs off the surface, that's the runoff that we're discussing. Okay, so when we look for runoff, that's what we're looking for. I'm going to dump out my 34 drops to test our next surface. Our next surface is clay. So I'm going to use Play-Doh as our clay. All right. And then I'm going to put it in there. It's about the size of a pepperoni. I'm going to put it half on the bottom and half on the side very carefully. I don't want to push down on the bottom. If I do, it would make holes in the clay. Okay, so I want it to be kind of flat, just like that. It looks kind of like a couch. And when I test this time, I'm going to rain right on top of the clay, and when it runs off and touches the plastic, we'll be done. Do you think that the clay will hold more or less than our hardscape did? Let's find out. Oh, I'm going to leave it flat. All right, let's see. 1, 2, 3, 4, 5. 5 drops, and it came right off the side to touch the plastic. Okay? The clay only held 5 drops. A couple reasons for that. One, it is on an incline, so since it's tilted a little bit, that could help that. It's also a little bit smaller than our hardscape surface was, right? And guys, it's already wet, okay? So the water moves off of it really easily. You ready for the next one? As we dig underground, we have our hardscape and our clay already, but we're actually gonna build or do the sand next. So when I put the sand in, there's a little lip on the bottom of my cup. I'm gonna put the sand in up to the lip on the cup, okay? It's about that much, right up to there. So it's not too much sand, but I do have a couple questions for you. Number one, does sand absorb water? What is sand really? It's tons of teeny tiny rocks, right? So they are gonna absorb the water, but if you've ever seen sand and poured water in it, it kind of feels like it does. You can squeeze it and it comes out. And that's because all those little tiny pieces sit next to each other, but they don't make it like a flat surface. There are tons of tiny holes. So instead of raining one drop at a time, we're having an issue with that. Because, guys, is there anywhere for it to run off to now? Right? Before it had somewhere to run off to, and this time it doesn't. So we're going to look for is saturation. All right? Saturation. Saturation is when it's so wet it can't hold anything else. Okay, it's got so much liquid in there, all that water, it can't hold anything else. Oftentimes when you see this, it'll look like a puddle. Now, I don't want to make a giant puddle because that'd be too much water. Okay, we want to see just how much it can hold. So what I'm going to do is when it starts to get a little bit shiny on top, I'll know that it's ready. And instead of raining one drop at a time, I'm going to use estimation. I tested this, and this particular dropper, when it gets up to this line, is about 50 drops. So I'm going to put this in here. It's all the way up to that line. So that's about 50 drops. It's almost shiny. I think it needs a couple more, but definitely not 50 more. So let's see. I can do 1, 2, 3, 4, 5, 6, 7. Yep. When I tilt it, it's just a little bit shiny, but there's not a giant puddle on top. So that's perfect. My sand is definitely saturated. So that was 50 and 7. So about 57 drops. Excellent. So the sand definitely holds a little bit more. It holds it in, right? Next up, rocks. If you've ever tried to dig in Texas, I've lived in a few different places in Texas. Everywhere when we try to dig to plant things, I've run into rocks. Okay, they're really hard to dig through, but they're really good for holding on to things like water. Do you think that with our rocks, they're going to hold more or less than the sand? Just like the sand, will the rocks absorb the water? Not necessarily, but there are holes between those rocks, and we're going to actually be able to see the water moving up. So this time for saturation, it won't be that it's shiny. We'll actually be able to see when the water gets right to the surface of our rocks. We're going to use estimation again to test this. All right, so I'm going to fill it all the way up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, almost 13. I'm going to put it flat. 14, 15. All right, you can see it. It's got right to the edge. So we had 15 droppers. So 15 droppers, and they're 50 drops each. So that's going to be about 750 drops. The rocks held way more than the sand. Okay, those spaces are huge between those rocks. There are different types of aquifers. There are different types of rocks. Some hold more and less water because they're more porous. They have holes in them that can actually hold on to that water. But all of those aquifers that we use, right, have the rocks around them to help hold that water in, because obviously that helps hold on to more, right, than the clay or the sand. But we need those layers in there too to help secure it. Now, what we're going to do next, I want to show you how they dig these wells into the aquifer. And so I'm just going to use my pipette. I'm going to do it away from the clay. So if you want to try this at home, make sure you don't put your pipette into the clay. All right. And when you do that, guys, I'm going to go ahead and squeeze the top part. And I'm just going to kind of gently push it in here. I'm going to pull it up. Now remember, we said aquifers are used for irrigation. About 76% of what our aquifers are used for in Texas has to do with irrigation. So we're going to pull this water out. We're going to say that was used for irrigation. That's not the only thing they use it for. Just like you and I, they use it for other things like, let's say, washing the dishes, brushing our teeth, taking a shower, all right? Oh, I don't know about you. I've got 3 dogs and a cat, so they definitely need some water, right? As you can see, guys, the more we take out, the lower the water gets. It used to be way up here, and now it's way down here, all right? When we look at that, if we use an aquifer too quickly and that level starts to drop, is it like our urban water cycle? Do we clean it and put it back into the aquifer? No. All right, it's a little bit different. For an aquifer to get recharged, for it to get more water, it has to rain. Now, we collect that water in the lakes, right, when it rains, to make sure our lakes stay the right level. We're really excited about that when it rains here in Texas. But also that water can go all the way through, past our surface water, like the lakes and the rivers, and it can come into our aquifers, all right? But do we get a lot of rain? Not usually. Okay, so we have to be very careful when we use our aquifers so that we don't drain them too quickly and they have a chance to recharge. Just like we talked about with the urban water cycle, with our wetlands, the amount of fresh water on our planet is so small. There are so many people and plants and animals that rely on that water. We have to make sure we're taking care of it. Okay, so even though we have all of these things to help us hold on to that water underground, it's still up to us to make sure that we're responsible with that water and that we're saving it when we can. When we brush our teeth, we want to turn the water off. When we take a shower, we talked about taking fast showers. Or even when we wash our hands, we can scrub our hands. And while we do that, we don't need the water on. We can leave it off and then turn it on just to rinse. Okay, what about something else? Let's see. We talked about washing dishes. When you wash the dishes, do you leave the water on while you're scrubbing the plates, or do you turn it off? Things like this, guys, if you have more ideas, we would love to hear them. We want to hear how you guys are learning about water at home, how you're saving water at home, and we want you to share those ideas with us. You can share them on our Facebook page, or you can email us questions and more ideas as well. Thank you for tuning in to learn about aquifers. I'm really excited to keep learning with you guys, and we look forward to hearing from you on the next video. Thank you.